Will Python SystemRandom, os.urandom always have enough entropy for good crypto? I have a password generator. According to the docs, SystemRandom uses os.urandom, which uses /dev/urandom to throw out random crypto bits. In Linux you can get random bits from /dev/urandom or /dev/random. They both use whatever entropy the kernel can get its hands on. The amount of entropy available can be checked with tail/proc/sys/kernel/random/entropy_avail. This will return a number like 129. The higher the number, the more entropy is available. The difference between /dev/urandom and /dev/random is that /dev/random will only spit out bits if entropy_avail is high enough, like at least 60, and /dev/urandom will always spit out bits. The docs say that /dev/urandom is good for crypto and you only have to use /dev/random for SSL certs and the like. My question is, will gen_pass be good for making strong crypto-grade passwords always? If I call this function as quickly as possible, will I stop getting strong crypto bits at some point because the entropy pool is depleted? The question could also be, why does /dev/urandom always produce strong crypto bits and not care about the entropy_avail? It is possible that /dev/urandom is designed so that its bandwidth is capped by the number of cycles you can guess will be correlated with an amount of entropy. But this is speculation and I can't find an answer. Also, this is my first Stack Overflow question, so please critique me. I'm concerned that I gave too much background when someone who knows the answer probably knows the background. Thanks. Update. I wrote some code to look at the entropy pool while the /dev/urandom was being read from. If run this and also run. Making the graph while running, cat/dev/urandom, look smiler and cat/dev/random, drops off to nothing and stays low very quickly. This also only reads out like a byte every 3 seconds or so. Update. So it looks like something is making it be the case that I have enough entropy. I should measure the password generation rate and make sure that it is actually being capped, because if it is not, then something fishy may be going on. Update. I found this email chain. This says that urandom will stop pulling entropy once the pool only has 128 bits in it. This is very consistent with the above results and means that in those tests I am producing junk passwords often. My assumption before was that if the entropy_avail was high enough, say above 64 bits, then /dev/urandom output was good. This is not the case. It seems that /dev/urandom was designed to leave extra entropy for /dev/random in case it needs it. Now I need to find out how many true random bits a SystemRandom call needs.
There's a subtle difference between the output of /dev/random and /dev/urandom. As has been pointed out, /dev/urandom doesn't block. That's because it gets its output from a pseudorandom number generator, seeded from the real random numbers in /dev/random. The output of /dev/urandom will almost always be sufficiently random. It's a high-quality PRNG with a random seed. If you really need a better source of random data, you could consider getting a system with a hardware random number generator. My netbook has a VIA C7 in it, which can generate quite a lot of properly random data. I get a consistent 99.9 kilobits per second out of /dev/random, 545 kilobits per second out of /dev/urandom. As an aside, if you're generating passwords, then you might want to look at Popen. It makes nice pronounceable passwords for you. Smile.
/dev/random/ will block on read if it needs more entropy. /dev/urandom/ won't. So yes, if you use it too fast you'll run low on entropy. Probably still quite hard to guess, of course, but if you're really concerned you can read bytes from /dev/random/ instead. Ideally, with a non-blocking read loop and a progress indicator so you can move the mouse around and generate entropy if needed.
You might want to read this about why /dev/urandom is the way to go. This URL.
If you want to see more, please consider subscribing.